Let us solve a question on cost functions. The question is, given the total cost function is total cost is equal to a plus b cube plus c cube square. TC denotes the total cost, Q denotes the output. We have to show that the marginal cost is equal to average cost, which is equal to b plus twice under root CA at Q is equal to under root A upon C, where average cost is minimum. Okay. Now we are being given this total cost function, or let's write it as C only. So we have this cost function. So first we need to find out the average cost and marginal cost, but we know that average cost is simply equal to total cost upon output. Okay, that means we divide this equation by Q. Okay, so we get A plus BQ plus CQ square, and if we divide it by Q, we will get the average cost is, and let's find it out. So which will be equal to A upon Q. Here Q gets cancelled, we get B plus here 1Q gets cancelled, we are left with CQ. This is the average cost function. Similarly, what is the marginal cost? Marginal cost is simply the change in the total cost due to the change in the output. The derivative of this function with respect to output. Since A, B, C are the constants here, derivative of A is 0, derivative of Q in the second term is 1, we are left with B, and the derivative of Q square is twice Q, so we will get twice CQ. This is our marginal cost. Okay, this is the marginal cost function. Now let's equate marginal cost function with average cost function to find out the level of output where both are equal. So average cost is equal to marginal cost implies average cost is this A upon Q plus B plus CQ, and we equate it with the marginal cost, which is B plus twice CQ. Okay, so here B and B will get cancelled, and if I transpose this CQ here, it will get subtracted, so twice CQ minus CQ comes out to be CQ, so CQ will be equal to A upon Q, so which implies Q cross multiplying, we get Q square C is equal to A, which implies Q square is equal to A upon C, or Q is equal to under root A upon C. Okay, transposing square, it becomes under root, and we only write here it is actually plus minus, but we negate the negative value because output cannot be negative. So Q is equal to under root A upon C is the level of output where average marginal cost is in fact equal to average cost. Okay, when Q is equal to A upon C. And here we can also find out this so we got marginal cost is equal to average cost, and corresponding marginal cost will be equal to simply plug the value of Q is equal to A under root A upon C in this marginal cost function or in average cost function. So we have B plus twice C, the value of Q is under root A upon C, so marginal cost will be equal to B plus, so C when multiplied with under root C, it will become twice under root CA. Okay, and if you put this output level into the average cost function, you will again get this very result for marginal cost function. Okay, now we are being also told that so at Q is equal to under root A upon C, where AC is minimum. Okay, next part will be to prove that in fact this point is, this level of output is actually the minimum point. For that, what will we do? Let's take the average cost function, minimum of average cost function. If I draw it like this, let us say this is our average cost function. So average cost will be minimum at a point where the slope of the average cost is equal to 0. Okay, that means what is the slope of average cost function is simply what we call the derivative of average cost function with respect to output, and when we set it equal to 0, we get a point level of output where the slope of average cost is minimum. So we need to take the derivative of the average cost function again. Okay, so what is the average cost function that we found out earlier? So this is our average cost function. Now derivative of 1 upon q square, so it becomes q raised power minus 1. Its derivative is minus q raised power minus 2. It becomes minus q upon 2 square. Okay, sorry, it becomes minus 1 upon q square. Okay, which implies, or let's write it here, derivative of 1 upon 1 upon q will be equal to minus a upon q square. Derivative of a constant is b, derivative of a constant which is b here is in fact equal to 0, and derivative of q in the last term is 1, so we are left with only c, and we set it equal to 0. Okay, solving again, you will find out that is a upon q square is equal to c, which implies q square is equal to c upon, or let's write it like this. We have q square c is equal to a, which implies q square is equal to a upon c. Again, q is equal to under root a upon c. To check whether this point is in fact the minimum point, what we need to do, we need to take the second derivative of the average cost function and check its sign. If the sign is positive, then we are in fact at minimum point. If the sign of the second derivative of the average cost function is what we call negative, then we have the maximum point. Okay, so first we take the first derivative. Now let's take the second derivative, that is d square ac upon dq. Let us find out the second derivative. This is in fact the first derivative. Now the derivative of minus a transpose this q square, it becomes minus 2. Its derivative, the derivative of k raised power minus 2 will be equal to, we have minus 2, then we have this minus a, then we have q by power function rule, minus 2 minus 1, so we get minus into minus is plus, so we get twice a q raised power minus 3, which is equal to twice a upon q cube. Okay, so derivative of a upon q square comes out to be, rather the derivative of minus a upon q square comes out to be twice a upon q cube, and derivative of a constant is 0. Now we have the second derivative. We need to evaluate it at the critical point that we got when q is equal to under root a upon c. Okay, so we have twice a divided by q cube minus under root a upon c. Okay, so we have q cube, so q is under root, it will be like this. It will be positive. Why? Because a is positive, c is positive. A and c are the positive constants, so it will in fact be greater than 0. That means q is equal to under root a upon c is in fact the point where marginal cost is equal to average cost and where average cost is minimum. Okay, so simple thing is, we took the first derivative, that is when we take the first derivative of the average cost function and we set it equal to 0, we got the critical point. Okay, to check whether that very critical point is in fact minimum or maximum point, we take the second derivative of the average cost function, and we evaluate it at the critical point that we got is q is equal to under root a upon c. Since it came out to be positive, that means in fact this is the minimum point. If second derivative came out to be less than 0, then we could have inferred from this scenario that average cost is maximum. Since it came out to be greater than 0, that means the slope is rising here. When the average cost reaches its minimum, to the left the slope is rising. That is being tested by the second order derivative. I hope I make myself clear in this video. Thank you.